First problem we'll solve is a die is rolled twice. Find the probability of rolling a 5, then a 1. These events are independent. When we roll the die the first time, it does not affect the die when we roll it a second time. First number we're looking for is a 5. There is one 5 on a 6-sided die. Over the possible outcomes, there are 6 different numbers that we could roll. So the probability of the first event, 1 out of 6 for rolling a 5. Multiplied by the probability of the second event. Probability of rolling a 1, there's a single 1 on a 6-sided die, again out of 6 total possible outcomes. Multiplying across, the probability of a 5, then a 1, would be 1 out of 36. Second problem will be the probability of rolling 2 different numbers, again when we roll a die twice. The first time that we roll a die, it does not matter which number we roll, so we could roll any of the 6 numbers out of the 6 possible outcomes. The second event, we have to roll a different number from one of the first 6 that we rolled. It does not matter which number we roll, there will be 5 different numbers besides that number. And again, there are 6 total numbers on a 6-sided die. Multiplying across, 6 times 5 would be 30 over 36. Reducing would be 5 over 6. So we'd have a 5 out of 6 chance of rolling 2 different numbers. For this problem, we'll be drawing letters from a word game, and we want to find the probability of drawing a E followed by a N if replacement occurs. Replacement means after we draw the first tile, we'll put that back in the box, and then we'll draw the second tile. Find the probability of E. Looking at the letters given, we have E, T, F, U, N, X, and P. There is a single E over 7 total tiles. So we have a probability of 1 over 7 for drawing a E. Multiplied by the second probability of drawing a N. There's a single N. After we draw the E, it is replaced back in the box. So there's still 7 possible letters. So there's a 1 out of 7 chance of getting a N. Multiplying across, our final probability would be 1 over 49, which is the probability of drawing a E followed by an N. For the second problem, we want to find the probability of drawing a X, then a P, if no replacement occurs. No replacement means after we draw the X, we'll take the X tile out. It's no longer in the possible outcomes, and then we want to draw a P after that. Again, the probability of drawing the X, there's a single X. There are 7 total letters at the beginning of this problem, so a 1 out of 7 chance of drawing an X. Once we take that X out, again the X is no longer among the letters, so it reduces our possible outcomes. Chance of drawing a P, there's a single P. And instead of 7 letters, since we took the X out and did not replace that, there are now 6 letters in the box. Multiplying across, our final answer for this problem would be 1 over 42, which is the chance of drawing a X, then a P, if no replacement occurs.